Hello everyone, welcome back to Blender CC Live Noding. In this episode, I'm gonna teach you how to create this procedural churros, the way I call it. Basically, you just need two different curve, and one curve is for the profile, and the other one is for the actual curve, and then you just simply bevel it. So this should be pretty simple. So let's get started from nothing. Okay. So this is Blender 2.80 and I will be using SketchUp nodes. And for what we are gonna create, we actually just use the torus nodes first of all, and we're gonna output the polygon, actually not polygon, polyline viewer. Polyline viewer is one node that actually generate curve output. Okay, so this is the torus node. We're gonna close it. We can control the radius, etc. And let's save this very quickly as Churos. Churos, if you don't know, Churos is basically like a donut, but it's usually it makes really long, and it has like a certain like a flowery shapes all over. It's not like smooth like this. It's not like a sausage. It's more like a, how can I explain it? There's some kind of a template. So we need to have a bevel, and for the bevel we also will be using SketchUp procedural way, and we need another polyline viewer. We're gonna call it something else better. So if we plug this in, we have a circle, right? And we want to close this as well. For this, we need to actually turn off the radius so that hopefully we can use it here. So apparently we cannot unless we turn off this bevel radius. Okay, and so it seems like we are getting somewhere. We have the bevel here. So the churros, actually the churros can be close or not close. Let me think. Okay, don't worry about that. But basically with the circle, I want to make some kind of a bit of variations. So in this case, I will be using scale. So circle and scale and the multiplier. So with the multiplier, we can use random number. And with random number, so depending on the number of circle here, the number of points in the circle, I will use a number which is an integer. Let's make it 12 and plug this into the circle, number of vertices and the number of random number here. For the random number, we can have any number, basically to represent the churros. Okay, so that's kind of the idea. So we are basically kind of done, right? So it's like it looks like an actual churros, more or less. Maybe use a Matcat for now, just a preview. Chocolate churros. This one, if we are using random number, right? But we can simplify this, maybe like to have like a kind of like a flowery look, like a star. So let's use this mask. If we have a data, plug in into that guy, and then we use the stethoscope. We have 1, but we actually want some kind of value, some kind of data value. So maybe let's use a range of number, the number count coming from this guy, and their output goes in there. So now we have this pattern 1 0 1 0 1 0 1 0. Okay, that's the pattern that we need, and we simply plug this into our multiplier. And of course, I forgot something. I need to also use the scalar math and multiply, or maybe add the value first of all, and then multiply the value. Oh, actually, maybe we need to multiply it and then add the value instead. So multiply and then add. So multiply will multiply the pattern 0 and 1. Add will give the radius value, so we can have our churros. So that's a procedural churros. If you want to play around a little bit more, you can, instead of using torus knot is actually very cool. You can have all kind of different shapes very easily, and you can actually turn on this spline so it's smooth. You can randomize it further. So it shapes a little bit more or less like a churros. It's not perfect. What would be nice is to have a texture that kind of make it like a something like a actual churros. Churros is something you can find in Spain, I believe, and usually served with coffee. So over there, if you go and have coffee, you can have churros, maybe $2, $3 for breakfast. All right, so this is a very long churros. You can open and close. So this is more like an actual churros, except that this one is not capped. So you probably want to cap it. So when I'm making 3D, oftentimes I'm more into outline. So some people think about the face, topology, things like that. I do think about that, but I usually think more in a parametric kind of way. So I really like outline and bevel, things like that. I don't know why. And with this churros, I forgot something. Oh, maybe we can also try using ellipse. Have you ever used ellipse in SphereChalk? Ellipse, of course, create ellipse, but this is actually a very powerful nodes, and there's a lot of possibilities here with ellipse. And if you use this with a circle, for example, quite possibly we can, maybe not with circle, maybe with a matrix normal first of all, and the circle. So circle, location, and the normal plug into the matrix normal. Matrix normal goes into the matrix, and you can have something like this. And this is, of course, very intricate, but we somewhat we can make this very complex result simply by using this setup over here. So I think this is quite interesting. And like I said, I like to think like this is 3D objects. It's of course just a bunch of curve. We probably need to convert this into mesh, and then I usually like to join it so it's become a single surface. We have that extra objects over there we don't want. Delete those vertices. But from these objects, if you ever want to print it out, it's actually possible. You just use something like remesh or voxel measure, auxiliary measure. Okay, but that's with Blender 2.81 or 2.82. However, very often remesh modifier actually can do the job. So it looks, topology wise, it's pretty meshy, but however, it can be 3D printed because it's a single surface and then it's an enclosed surface. Okay, I think it can be cleaner, but anyway, you get the idea. From these things like simple ellipse, you can have all kind of different pattern and design, and this thing still shaped like a churros, I believe. Did we lose our churros? Or maybe, I think we still have the shape of churros. I said it's we need to multiply it more. So by now it doesn't really look like, it doesn't matter if it's churros or not, but just an idea, because maybe in the next video I talk a bit more about this. But with the torus knot, we actually do have the shape of churros. Oops, that's super complex. Let's get rid of this for now. Okay, back to the simple churros, mathematical churros. All right, thanks again for tuning in, and I'll see you next time. Thank you. Bye.